Hello, I'm Abdurrahman Zain. I'm a fifth year medical student, and today we're going to talk about saliva. Alright, as you can see here, saliva is essentially means the spit and this secretion, this cute secretion that comes from this cute baby. And in today's video, we're going to talk about the learning objective, which is going to be what is saliva, like what it contains of or consists of, how it's made, and how the steps involved in the secretion, its importance, and how we control the saliva secretions, or how the body controls the saliva secretion. All right. So what I want you to think about when we think of saliva, I want you to think about your mouth being a factory that produces the saliva. And there are three main machines that produces saliva, or they are the only machines that produces saliva. And they are the parotid gland, the submandibular gland, and sublingual gland. They are the ones that produces saliva. They produce about 1,500 milliliters of saliva per day. And saliva consists of mainly water. It consists of protein and enzymes as protein. And there are two enzymes. The first one is called the ptyalin. And ptyalin enzyme, And ptyalin enzyme is essentially alpha amylase enzyme, and this breaks down starch into simple sugar. And the other one is mucin. Mucin is a protein that is slippery. It's thick and slippery, and it's used as a lubricant. And of course, the pH should be neutral, because if it's acidic, is going to destroy our teeth. Now, if we zoomed in one of the glands, we will find that there are many kind of cells, but the most important cell that we want to focus on is called the acinine cell. And the singular term is acinus. And these cells are the secretory epithelial cells. These are the cells that produces the saliva. They are the cells that forms the saliva. And saliva is mainly watery and thick part. The watery part, which we call it the serous, and so there is a type of acini cell. It's called the serous, and this is the one that is responsible in producing the watery part, which is called the serous. And the mucus, which is the thick part, is from the mucus acinus. All right, and our glands, we talked about that there is a parotid, sublingual, and submandibular gland, and these are the ones that produces the saliva. All right. But the thing is, not all of them produces the same part of the saliva, and not all of them produces the same amount. Regarding the parotid, there's this simple technique that I use to make it easier to remember what each gland produce. Parotid come from pure watery. So it's mainly, or it just produces serous type. And the sublingual is sublingual from the L, slimy. It's slimy mucus. So it produces mainly the mucus, the mucin. And last but not least, with submandibular, which is split between both, and it produces mixture, serous and mucin. Regarding the amount, let me just zoom in so that I can write. Regarding the amount, the most one, or the highest one, is the submandibular. It produces 70% of the saliva we produce every day. Sublingual is the least, which comes at 5%, and the parotid is before the least, which is 25%. Okay. Now on to the other one, which is we know how to produce saliva. Now, how will it reach our oral cavity? Before, it cannot just go from the gland into the oral cavity or our mouth just right away. It needs to be modified in order to make it suitable for our mouth. So, as we said, that the acinine is they are the cells that produces the saliva, but it does not produce the saliva we taste right now. It produces something called primary saliva secretion. Primary, which is the first batch of the saliva. And this primary saliva is has the same ionic composition of the extracellular fluid. And the ionic composition of the extracellular fluid is isotonic, which means it has high sodium, high chloride, low potassium, and low bicarbonate. Okay. And we cannot, our body cannot just produce primary saliva and secrete these primary saliva, because as I said, it has a lot of sodium, a lot of chloride, and it has low bicarbonate. And the thing is, we produce 1,500 milliliter of saliva every day. So that means it will contain a lot of sodium content, and sodium is very valuable for our body. So wasting this much of sodium every day is going to just a waste of sodium, waste of a valuable electrolyte. So what our body will do is that it will reabsorb this kind of sodiums from either active transport. It's actively transported by the cells of the duct cells. The parotid, the gland ducts. The cells has some kind. It's modified in a way to make the sodium to be actively reabsorbed into our body. And also we aldosterone, which is the hormone that acts on the kidney to make it reabsorb sodium, also acts on the saliva and also the salivary glands and the salivary ducts to also reabsorb sodium. Okay. And of course, we need high bicarbonate ions in the saliva, because we need a buffer to neutralize any acidic food that we eat. All right. So as you can see here, if you look closely, these are the acinine cells. They are grape-like cells. Here they produce the isotonic, which is the saliva, which is the primary saliva, and as it moves through the duct into the oral cavity, here something happens. Sodium is actively transported and actively reabsorbed, and the chloride is passively reabsorbed. It follows the sodium. Potassium is secreted by the ductal cells, and so as the bicarbonate. So the net result of this mechanism is that we get a hypotonic solution. So our saliva that we taste right now is in the hypotonic solution compared to the plasma, or compared to the extracellular fluid. So it has low sodium, low chloride, and of course high potassium and high bicarbonate. Okay, but there's a catch. There is an instance where, and this is the only instance, where the saliva that reaches our oral cavity have the same ionic composition of the plasma or the extracellular fluid, and the instance is that it's called maximum salivation. Is that when we eat something very delicious, our saliva flows so fast that the duct don't have the time to in order to reabsorb the sodium or to secrete potassium and bicarbonate. So this is the only instance, and it doesn't happen that much. Now we're going to talk about the functions, and in order to remember the function of the saliva, we need to remember the specific characteristics of it, so it will make it easier for us to understand and to remember all the functions. So there are essentially 6 functions. The first 2 is to protect the mouth, and protect the mouth because the saliva is mostly water, and it has a pH of 7. So in this case, water will cool any hot food. This is the first one to protect the mouth. And also it has a pH of 7, which is important to neutralize any acid that we eat from other foods, and also to neutralize any epigastric and any gastric reflux. If we have any reflux, it's acidic, so it will neutralize this acid. Fight bacteria. I didn't write this, but saliva contains lysosomes. It contains immunoglobulin, and it contains these two. They fight bacteria and they kills bacteria. It's good for our health, for protection of our bacteria. Now, it protects our teeth by two ways. The first one is that it has a pH of 7, so it neutralizes the mouth and keeps it in a neutral pH, because the enamel is a very sensitive part of the teeth, and any acid will break it down, and so it's important to have a buffer and a neutralized solution in our mouth. Digestion. It contains two enzymes, which is amylase enzyme, which breaks down starch into simple sugar, and this is from the ptyalin, the ptyalin, right? Lubrication comes from mucin, and wetting. Lubrication and wetting comes from the mucin, and it's also important in keeping our mouth wet, and this is important to stay away or protect our mouth from ulceration and infection, because there is a condition called xerostomia, where xerostomia essentially means dry mouth, and having dry mouth will increase the instance of us having ulcers, having infections, and so it's important for our mouth to stay wet all the time, and also to talk fluently and to speak loud. We need also our mouth to become wet. And I forgot about something regarding the protection of teeth. See, in the water we drink, there is fluoride. There is a little bit of fluoride in it, and fluoride excretes in the saliva, and so when it excretes in the saliva, of course it reaches, it's contacted the enamel, and enamel is protected by the fluoride. This is just one thing about the function of the saliva. Now we're going to talk about the secretion control. Okay. See, our saliva is continuously secreted throughout the day. So we continue as we are awake. We continuously produce saliva. So our saliva looks like this. It's a continuous production. But there are two ways to increase the secretion. So either from outside, something that is not related from the body, food will increase our salivary secretion, because we need saliva to dissolve the substance that makes us taste the food, to make it easier to swallow, and so on. So food is one of the things that increases our saliva. And also there is something called the autonomic stimulation. We have the parasympathetic stimulation and the sympathetic stimulation. And the parasympathetic stimulation is the one that increases the salivary secretion. The two things that decrease the salivary secretion, first is atropine. Atropine decreases salivary secretion and any cholinergic blocking agent, and the sympathetic stimulation decreases the salivary secretion. Now we will talk about the innervation of let me just zoom out. The innervation of the salivary gland. All right, of each salivary gland. So the innervation of the parasympathetic innervation. First, there is two main ganglion, which is the otic ganglion for the parotid gland, and the submandibular ganglion for the submandibular gland and the sublingual gland. So the preganglionic, it arises in the medulla. We have superior and inferior the salivary nuclei. Let me just zoom in. Nuclei. Regarding the superior salivary nuclei, it goes through the fiber, the efferent goes through a pathway called the chorda tympani, and then it reaches the submandibular ganglion, and the postganglion fibers, they relay in the submandibular gland and the sublingual gland. And regarding the inferior salivary nuclei, also in the medulla, it goes through the pathway of the glossopharyngeal nerve, and it relays in the otic ganglion, and this relays in the parotid gland through the auriculotemporal nerve. Okay, so these essentially the parasympathetic innervation and its pathway. Regarding the sympathetic pathway, it comes from the lateral horn of the first and the second segment of the thoracic vertebra. And if you look closely, here it is. So the sympathetic comes from the first and the second lateral horn of the thoracic segment of the vertebral of the spinal cord, and it goes to this ganglion, which is called the superior cervical ganglion. It relays into the parotid gland and submandibular gland. And here is these are the sympathetic, innervation of the salivary gland. Okay, and that's it. Thank you for watching, and I hope you learned something.